The National Electrical Code Section 404.6 states that single-throw knife switches shall be so placed that gravity will not tend to close them. This means that the switch must be mounted so that the handle is in the off position when the switch is not in use. The NEC does not require the line side of a switch to be on top and the load side in the bottom. It is common practice to do so because it simplifies tracing the flow of electricity through the circuit. The National Electrical Code Section 240.81 states that on circuit breakers the handle position up shall be the on position. This means that the circuit breaker must be mounted so that the handle is in the on position when the circuit breaker is closed. The NEC does not require that the line side of a circuit breaker be on top and the load side in the bottom. However, it is common practice because it makes it easier to trace the flow of electricity through the circuit. Generally, it is best to mount electrical devices so that they are easy to operate and maintain. Switches and circuit breakers should be mounted at a convenient height, and the line side of the device should be easily accessible. When installing electrical devices, it is important to consider several factors to ensure safety, compliance with codes, and ease of maintenance. One key aspect is the orientation of devices such as switches, circuit breakers, and contactors, especially when they are mounted vertically. While the NEC provides specific guidelines for certain aspects of device orientation, it's crucial to understand the underlying principles and best practices. Regarding knife switches, the NEC in Section 404.6 explicitly addresses the placement of single-throw knife switches. The requirement is that these switches must be installed in a way that gravity does not tend to close them. This is a safety measure to prevent the switch from accidentally closing due to its own weight or vibration, which could energize the circuit unexpectedly. Therefore, the switch should be mounted so that the handle is in the off position when not in use, ensuring that gravity acts to keep it open. For circuit breakers, the NEC Section 240.81 specifies that the handle position up shall be the on position. This is a standardization measure to ensure that the position of the handle clearly indicates the state of the circuit breaker. When the handle is in the up position, the circuit breaker is closed and the circuit is energized. Conversely, when the handle is down or in the off position, the circuit breaker is open and the circuit is de-energized. This consistent orientation helps to avoid confusion and potential hazards. While the NEC provides specific requirements for knife switches and circuit breaker handle positions, it does not mandate that the line side of a switch or a circuit breaker be on top and the load side on the bottom. However, this is a common practice in electrical installations for several reasons. Firstly, it simplifies tracing the flow of electricity through the circuit. By consistently placing the line side on top and the load side in the bottom, electricians can easily identify the source of power and the path it takes to the load. This can be particularly helpful when troubleshooting or making modifications to the circuit. Secondly, this practice can contribute to a more organized and visually intuitive installation. When all the switches and circuit breakers are wired in a consistent manner, it becomes easier to understand the overall layout of the electrical system. This can be beneficial for both electricians and anyone else who may need to work on the system in the future. In addition to these practical considerations, there may be other factors that influence the decision of whether to place the line side on top or the load side in the bottom. For example, the specific design of the equipment being used may dictate a particular wiring configuration, or the physical constraints of the installation location may make it more convenient to wire the devices in a certain way. Ultimately, the decision of how to wire the switches and circuit breakers should be based on a careful consideration of all the relevant factors. While there is no specific NEC requirement mandating the line side of a switch or circuit breaker be on top, common practice often dictates this arrangement for ease of tracing circuits. The NEC focuses on safety and functionality, such as preventing gravity from closing knife switches. Section 404.6 and ensuring circuit breaker handles indicate the on position when not. Section 240.81. The best approach to mounting electrical devices is to prioritize ease of operation and maintenance. This includes mounting switches and circuit breakers at a convenient height and ensuring that the line side of the device is easily accessible. The NEC provides a comprehensive framework for electrical installations, but it is essential to understand the underlying principles and best practices to ensure safety, compliance, and ease of maintenance. Always consult the latest edition of the NEC and any applicable local codes to ensure that your electrical installations meet all requirements. When mounting electrical devices such as switches, circuit breakers, and contactors vertically, several considerations should be taken into account to ensure safety, functionality, and compliance with the NEC. Firstly, accessibility is a key factor. Devices should be mounted at a height that allows for easy operation and maintenance. The NEC does not specify exact heights, but it is generally recommended to follow the guidelines in the Americans with Disabilities Act, which provides recommendations for accessible reach ranges. This ensures that the devices can be operated by a wide range of individuals, including those with disabilities. Secondly, the orientation of the device itself is important. As mentioned earlier, the NEC section 404.6 requires that single-throw knife switches be mounted so that gravity does not tend to close them. This means that the switch must be oriented so that the handle is in the off position when not in use. Similarly, the NEC section 240.81 requires that circuit breakers be mounted so that the handle position up is the on position. These requirements ensure that the position of the device clearly indicates its state. Thirdly, the wiring of the device should be done in a way that is safe and easy to understand. While the NEC does not mandate that the line side of a switch or circuit breaker be on top and the load side on the bottom, this is a common practice that can help to simplify tracing circuits. When wiring the device, it is important to use appropriately sized conductors and to make sure that all connections are tight and secure. Additionally, it is important to properly ground the device to protect against electrical shock. Fourthly, the physical environment in which the device is mounted should be considered. If the device is located in a damp or wet location, it must be protected by an enclosure that is rated for that environment. The NEC specifies different types of enclosures for different environments, such as NEMA 1, NEMA 3R, NEMA 4, and NEMA 4X. It is important to choose the appropriate enclosure to protect the device from moisture, dust, and other contaminants. Fifthly, the device should be properly labeled to indicate its function. This can help to prevent confusion and ensure that the device is operated correctly. The NEC requires that all electrical equipment be labeled with its voltage, current, and other relevant information. Additionally, it is helpful to label the device with its function, such as lighting circuit or motor circuit. In summary, when mounting electrical devices vertically, it is important to consider accessibility, orientation, wiring, environment, and labeling. By following these guidelines, you can ensure that the device is safe, functional, and compliant with the NEC. Here are some additional details to consider when mounting specific types of electrical devices. For switches, the NEC provides specific requirements for the installation of different types of switches, such as snap switches, dimmer switches, and knife switches. These requirements cover topics such as the mounting height, the type of enclosure required, and the wiring methods that are permitted. When installing switches, it is important to follow these requirements carefully to ensure safety and compliance. For circuit breakers, the NEC provides specific requirements for the installation of circuit breakers in panel boards and other enclosures. These requirements cover topics such as the spacing between circuit breakers, the type of overcurrent protection required, and the labeling of circuit breakers. When installing circuit breakers, it is important to follow these requirements carefully to ensure that the electrical system is properly protected. For contactors, the NEC provides specific requirements for the installation of contactors in motor control centers and other enclosures. These requirements cover topics such as the wiring methods that are permitted, the type of overload protection required, and the labeling of contactors. When installing contactors, it is important to follow these requirements carefully to ensure that the motor is properly controlled and protected. It is important to consider the specific application and environment when selecting and installing electrical devices. For example, in a commercial kitchen, devices must be resistant to moisture, grease, and high temperatures. In a hazardous location, such as a chemical plant, devices must be explosion-proof. In a healthcare facility, devices must be tamper-resistant. By carefully considering the application and environment, you can choose devices that are safe, reliable, and compliant with the NEC. It is also important to stay up to date on the latest changes to the NEC. The NEC is revised every 3 years, and the changes can have a significant impact on electrical installations. By staying informed about the latest changes, you can ensure that your installations are always in compliance. The National Electrical Code serves as a cornerstone for safe electrical installations. It's updated regularly to address new technologies and evolving safety concerns. Familiarizing yourself with the latest edition is crucial for anyone involved in electrical work. Consider subscribing to industry publications or attending training courses to stay informed. The NEC doesn't provide explicit instructions for every possible scenario, so understanding the intent behind the rules is essential. This involves not just memorizing code sections, but also grasping the underlying principles of electrical safety. For example, grounding and bonding are fundamental concepts that prevent electrical shock hazards. The code mandates specific methods for grounding and bonding, and understanding why these methods are necessary is just as important as knowing how to implement them. Proper installation techniques play a vital role in ensuring the long-term safety and reliability of electrical systems. This includes using the right tools, making secure connections, and protecting conductors from physical damage. When working with electrical devices, always follow the manufacturer's instructions and use appropriate safety gear, such as insulated gloves and safety glasses. Regular inspections and maintenance are essential for identifying and addressing potential electrical hazards before they lead to accidents. This includes checking for loose connections, damaged wiring, and overloaded circuits. Implementing a preventative maintenance program can significantly reduce the risk of electrical fires and other incidents. Remember, electrical work can be dangerous if not performed correctly. If you are not a qualified electrician, it's best to leave electrical installations and repairs to the professionals. Safety should always be the top priority when working with electricity. In addition to the NEC, local codes and regulations may also apply to electrical installations. These codes may be more stringent than the NEC in some areas, so it's essential to be aware of them and comply with them. Check with your local building department to determine the specific requirements for your area. Continuing education is crucial for staying up to date on the latest electrical codes and best practices. There are many resources available for electricians and other electrical professionals, including online courses, workshops, and seminars. Investing in continuing education can help you improve your skills, enhance your knowledge, and advance your career. The NEC is a complex document, and it can be challenging to interpret some of its provisions. If you're unsure about the meaning of a particular code section, it's best to consult with a qualified electrical inspector or engineer. They can provide expert guidance and ensure that your electrical installations comply with all applicable requirements. Electrical safety is a shared responsibility. Everyone, from homeowners to electricians, plays a role in preventing electrical accidents. By following the NEC, using safe work practices, and staying informed about electrical hazards, we can create a safer environment for ourselves and others. Electrical systems are dynamic and can change over time. As new technologies emerge and energy demands evolve, the NEC is constantly updated to reflect these changes. Staying informed about these updates and adapting your practices accordingly is essential for ensuring the continued safety and efficiency of electrical installations. Effective communication is essential in any electrical project. Clearly communicate with your colleagues, clients, and other stakeholders to ensure that everyone is on the same page and that the project is completed safely and efficiently. Keep detailed records of all electrical work performed, including wiring diagrams, test results, and inspection reports. These records can be valuable for future maintenance and troubleshooting. Finally, never compromise on safety. If you're unsure about something, ask for help. It's always better to be safe than sorry when working with electricity.